Hi, Ken from Tanning Bed Repair Guide. So this video is about voltage difference. The reason why you want to know about voltage difference is for troubleshooting, or else it can be extremely confusing to measure. Let me bring a gauge in just so that we can play a little around with some physical things here. All right. So let's take three-phase. The same rules applies for single phase. It's a little bit more simple with single phase because you only have two power legs going on. So let's remove this for right now, right there. So you have the three phases of 120 volts a piece. And in a commercial building in America, you usually would measure 208 between them. So if you take your gauge like this is a Fluke, very nice meter, and put that to voltage AC. It's the little wave. And you measured power coming in right here across. You will measure 208. For a residential building, it will usually be 240 that you measure across there. That's how the phases are kind of interacting with one another, that creates that timing difference that offsets the difference between them. So they are actually looked at as different power sources. So this 120 is not the same as this one. These two you can't like just put together. That will create some nasty arcs because they're not the same. So one has a potential 120 in one time period and the other one in another time period. And because of this difference between them, you will have that, like for a residential building, 240 across here. So let's use that as an example, because once you get into 208 and tanning beds, you need buck booster, transformer, and stuff like that, and it starts to get a little bit more complex. But you know what? This is actually probably more for, this video is probably going to be more for people with an actual booster. So let's say that the power comes in from the booster here. Then these two voltages, like the voltages here, you'll boost those up. So you'll probably have more like 135, 135, 135, something like that, 130, whatever. So in the end, and then once you measure across here, you measure 230 volts. So when you take a gauge and measure across there, you will have 230 volts. These right here, I put in here are fuses. So a fuse is just like a thin piece of wire, essentially, in a little component of sand to lead away the heat. And if they get enough power, which they're rated for, they will burn in half and disconnect, just like a switch. And so after that, you need something to turn on your light circuit, and that will be your contactor. That's the big square thing. You might have several of them, but typically there will be a main contactor coming in. How you will troubleshoot a contactor like that and the fuse, we'll get into that in this video. So the load, like the lamp, works on voltage difference, and the lower resistance that lamp has, like the easier it is from the power to get from one side to the other, the more power, the more current that will run. So let's do that. Let's put a lamp right here. This is a light. This is like a basic light. This is actually not a tanning lamp when it's looking like that. It's like an old school incandescent lamp typically when you're showing it like that. So because you will need ballast and a starter and stuff like that, I mean, in your circuit to run this. So, but anyway, let's use an old lamp. This is because for this it will be too complex to also take in that whole mess. So an incandescent light, and you connect your leads there. So now when you turn on K1, like you put power to that relay, there's also a video on how a contactor works, so when you engage that, you put power to it, it drags down these contacts, that makes connection, boom, boom, across here, all three. Now this 130 volt goes through there and over here and goes over to here. And the same goes for this 135. It's over here now. And the voltage difference is between them. And now they're connected through the bulb. So depending on how easy it is to get through that bulb, the electrons now will start to travel from one side to the other, using each other as the opposite potential. And so you will now have that 230 volts over this light. So if you took your gauge now, and you have power going out there, you will measure 230 volts across this lamp. And so if, let's say, that the fuse gets blown, like that, disconnected, now you don't have any light out there. The fuse is out. So this works exactly the same as if this switch here in the contactor got turned off. So now, how do you find where the power went out? Well, what you do is that you can see that the contactor is still on. That means that what you do is that you just measure across here. So you measure here, you measure 0. And that actually means that that it's turned on. If it measured something, that will be your problem. So that's what will happen. If you measure here, you see the 135 is here from this side, and the 135 can run all the way through the load, everything's connected all the way up to this point. So now you will measure 230 volts across this fuse. Let's replace the fuse. Boop, 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 boop. New fuse in. Now you measure 0 because you have the power that can just go through. There's no difference from this point to this point for the power. It can just go right through all the way up here again, and then across that load you measure your 230 volts again. So that's how you can find a fuse. When you have everything engaged, you can like measure 230 volts across here, and then you measure voltage here, but you measure no voltage here. That fuse is most likely dead. Now, another scenario, very common scenario that's more tricky, is if at the contactor, the big contactor, one of the surfaces here gets damaged. That happens. Like if dirt gets in there or something like that. It can be various reasons, or just overload, simply overload. And it arcs out and it melts, and now there's no connection. So when that engages physically, clunk, the contactor goes down. Even so, let's just show that, like this, right? And then, but the surface is broken. Then, well, the same thing happens here. You will have 230 volts here. You'll have 135 going up to this point where it's broken, and then you have the voltage coming from the other side all the way up to this point. That means that you measured here, it was 0, because there's no difference from this point to this point electrically, but there is now here. There you will measure 230 volts because one is standing on one side, one is standing on the other side. You would have no light in there because you don't have a closed circuit. But that's how you measure if a contactor is out. Because you can't pull the you could pull the contactor apart to see if there's anything wrong with it, but in the process you might actually destroy it. But so that's how you measure it, by using that voltage across here. That's how you determine if a contactor or a fuse is blown quickly. This is a very smart way to troubleshoot. Ken from 10-Bit Repair Guide. Take care, guys.